Welcome, my name is Terry Soul and this is Programming Chaos, a channel devoted to fun and interesting programming projects to help you hone your programming skills. For those of you who have watched some of the other videos on my channel, you've probably figured out by now that one of the things I love about computer programming is that with a little creativity and some innovative applications of mathematical concepts, you can create all sorts of amazing projects. For example, today's project, which is this colorful day-night cycle. It involves a couple of different ideas that have showed up in other videos. So for example, the sky is created using colors from the color wheel. So we'll talk a little bit about how the color wheel is arranged and how we can leverage that to get these effects. We use some recursion to create this beautiful silhouette of a tree. And we actually end up using a little bit of trig to handle the day-night cycle. In addition, an array list so that we can store our stars, and we put all of those together and we get this nice animated image. I should mention before I get started on the programming itself that this project was inspired at least in part by one of my kids' favorite books when they were growing up, The Day the Babies Crawled Away by Peggy Rathman. So if you happen to have little kids and you're looking for a good bedtime story, I recommend it highly. With that in mind, let's get started with the programming. Let's start with the color wheel, which we'll be using to get this colorful background. So this is a standard color wheel. It starts at 0 degrees and goes around 360 degrees. And so you can see all of the colors are aligned with different locations around that wheel. And if, like me, you struggle a little bit with coming up with good color choices for projects, understanding the color wheel and a little bit of color theory can be helpful. I'm not going to go into the details of color theory. There are lots of other good videos and websites on that, but a couple very basic ideas that are helpful to know. Colors that are on opposite sides of the color wheel are complementary, and they tend to stand out very boldly if you use them side by side. Colors that are close to each other on the color wheel are analogous, and they give you sort of a more subtle variation. And there's a lot more to color theory than that, which I won't go into because frankly, I only sort of understand it myself. But for this project, what we want to do is create this colorful background. And I want to start sort of with blues, especially light blue towards the top of the sky, getting darker in sort of a sunset effect, and then shading into reds and oranges and yellows to sort of get that full sunset, or if you prefer, sunrise effect. And so really, I'm just going to be drawing colors from this region of the color wheel, starting at the top of the screen in the blues and moving around into the yellows as we go down the screen. And if I just did that, we'd get a very uniform distribution. In fact, what you saw before was more random variation. And so I'm going to apply those colors randomly, starting over here on the color wheel, and then selecting random values from a range that has a little bit of positive and a lot of negative. So every step as I move down the screen could move a little bit to the positive, but is much more likely to move to the negative. So on average, we'll move around into the yellows, but with a little bit of variation, which gives the variation in the sky that's so nice. So that's the idea for the color wheel. One other trick that we have to worry about as we do this is I'm going to need to redraw it over and over again. And then as the day changes, I'm going to need to redraw a new, different random set of colors. So I'm going to have to do some little tricks in terms of my random number seed. I'll actually set a random number seed, use it to generate a sky over and over again. And then as it turns out in the code, when it gets to be midnight, I'll reset that seed. So the next day we get a different random sky that can still be drawn repeatedly if we need to. That'll become clearer once I start putting in the code. So let's go ahead and do that. And here, like I say, I want to do the rainbow sky. So this is where I'm starting with the code, the standard setup and draw for processing. And I'm going to need to store all of my hues as I go through the colors of the sky. So the first thing I'm going to need is an array to store all of the colors. The size of that array will be equal to the height of the screen because I'm going to have one line of color for every row in the screen. And I need to set my color mode to actually be hue, saturation, and brightness so I can take advantage of the color wheel. So the way this works, I'm using hue, saturation, and brightness. The hue, that is the color choices, go from 0 to 360, so that gives me a color wheel. And then for saturation and brightness, I want those to range from 0 to 100. As I said, I also need a random seed, so every day I'll reset the random seed and get a different random sky. This is going to be the random seed I'll use before choosing and drawing the sky. Now that I have that seed, I'll call a generate sky function, which admittedly doesn't exist yet, but I'll just need to write that. And then as part of my draw loop, I will draw that sky. And of course, I have to create both of those functions. So let's start with generating the sky. I'll begin by using my sky seed to set the random number. That sets my random seed for generating the sky. And like I said, at what is effectively midnight, I'll change that so I get a new sky each time. And then I want to start my hue at 190. So that puts me in the light blue range of the sky. So that's where I want to start. And then I simply want to move basically down the screen, calculating what the new color will be at each location on the screen. So there's the beginning. I start at 190 and I make that the first color in my array. And then I have to pick the next color that comes after that. So what I want to do is make sure that I move down the sky sort of consistently plus some random noise. And so there's a few different ways to do that. This is the approach I'll take. It's the old hue plus the total distance I want to move around the color wheel. So I want to move around 240 degrees. That will take me into the yellow region. And I divide that by the height of the screen. So each step is a consistent step down. And if I just do this, I'll get a nice smooth set of colors from the color wheel. Notice that I have to put in a float here because otherwise I would be doing integer division and I wouldn't get the decimal place that I might need. And then I'll add to this the random factor. And because I'm always stepping ahead by a fixed amount, my random can actually be uniform. So I could back up a little bit or go forward a little bit, but I'm always on average moving forward through the color wheel. And then the other issue is I'm starting at 190. And as I move through the color wheel, when I get to 360, I actually want to cross past 360 back to 0. So I put in a modulus 360 to get back around to 0. And the final thing that is not generally necessary but is helpful is to put in some limits. So it turns out if you go much past 70, you're getting into the greens, which looks weird on the screen. So I'll put in an extra limit here. There we go. And you'll notice with a lowercase h that I've got two conditions. If I'm larger than 70, I want to go to 70. So that keeps me from moving too far into the green. But I also have to say I'm less than 180 because I start at 190 and I don't want the 190 to be reset to 70. So this generates the sky for me and stores it in an array. And then to draw the sky, all I have to do is work through that array. There we go. And so notice that I'm setting the hue based on my stored hue values. I'm using maximum saturation and brightness for now. So this is sort of going to be the full daylight effect, if you will. And then I'm drawing the line all the way from the left of the screen to the fully to the right of the screen at that Y height. So let's see if this works. Not quite, because I'm missing a closing parenthesis there. Oh, well, and I used the wrong variable, so let's switch this to y. So there we go. And this gives me my range of colors, and you'll notice that there's some variation. There's some lines in there based on this random factor. If you think those are too strong, you can make the random factor smaller. So say -1 to 1 would give a little less variation. I've made it pretty strong just so it stands out well. And if we run this again, it looks fairly similar but not identical. So we're going to get little variations each time. So that's how we get the sky, just by moving through our color wheel with a little bit of random noise. So a couple of places we can go from here. We can put in the day-night cycle, but I think I will put in the tree next instead. So I actually have two things to include, and I handily have this as my background. They're sort of the ground, if you will. And the way that works, it's just a really big circle. The center point is way below the window. So we just see a little arc, and then we put in a random tree. I'm going to do this as two functions. The first one is just my draw ground. And of course, again, that doesn't exist, so I need to add it. I'll put it down here at the bottom. And all I really need for it is a giant circle. So if I run this, we now have our ground put in. And then the next thing I want to do is add the tree. And for that, we're going to do a recursive function. So if you look at the tree here, there we go. It's basically a branch followed by 3 more branches. And each of those is followed by 3 more branches and 3 more branches and so forth. So this is a fairly standard recursive function, branch, which then calls itself 3 more times to draw the other branches. And in order to set this up right, I need to decide where to put the tree first. So what I'm going to do is a little bit of translation so that I'm on the right location on the screen and facing in the right direction as I go to draw the tree. There we go. So I'm using the push and pop matrix to translate my coordinate system. I'm moving them to be about 1/3 in from the left of the screen, and at the bottom of the screen -50, which is up a little bit. So my tree is going to start about 1/3 of my window in and a little up from the bottom. The rotating -0.5 times pi, in processing 0 degrees is off to the right. I want 0 degrees to be up so that as I draw that first branch, it goes up and then starts branching. So I'm, again, moving my coordinate system and rotating them so that now the x direction is up. And it turns out for the branching function, what I really need to do is tell it how big I want that first branch to be, how long. And we haven't written the function yet, but the idea is I'm going to say, well, I want that first branch, which represents the trunk, to be, for example, 160. And again, this is a number you can play with if you want bigger or smaller trees. Okay, and so now I can go in and draw that tree. And so my branch function takes the length and is going to draw a branch, and then in this case 3 branches coming from that branch. This is a recursive function call, so I'm going to start with the stopping condition. When my branches get to be short enough, I don't want to keep drawing because otherwise I'll get into infinite recursion. So again, a little bit arbitrarily, if the length is less than 3, I'll return. And then I want to go ahead and draw the branch. So the width of the branch is going to be basically 15% of the overall length. So for a particular length, I know what the width is. Again, an arbitrary number that you can play with a bit if you want. And then I simply draw in my line for that branch. And this is, of course, not recursive yet. This is just drawing in a line. And you may be wondering a little bit, well, if the line goes from 0, 0, shouldn't that be in the corner up here? No, because I've done this translation. So the starting location is at that new position. And again, if you're familiar with lines, this feels like I should be moving in the x direction. But because of my rotation, the x direction is now up. And I just find it a little easier to think about my recursion as moving up. I should mention, if you really like drawing trees, I've got a couple of other videos which I'll link up above that talk about other ways to make trees, including three-dimensional trees that you can rotate and brightly colored trees instead of just these sort of plain silhouettes, and even some additions of things like leaves and fruit if you want. But for this, I just want to stick with our simple silhouetted tree. And if we run this, of course, we don't have the recursion, so all we have is the basic trunk of the tree. So now we can put in the recursive call, and that basically says, I want to make several additional branches, in this case, 3 more branches. Let me scroll down a little bit here. I'm translating now to the end of the branch I just drew. So if you think of this as the branch I just drew, I'm moving my coordinate system here so the other branches can be drawn from 0, 0. And then I want to draw 3 branches. So I'm going to use a for loop, and I'm actually going to do a negative, a 0, and a 1, and I'll use those to adjust my angles. So the negative angle will be to the left, the 0 will be straight up, and then I'll use the 1 to be to the right. And now I'm going to push another matrix because I'm going to do another transformation of my coordinate system. So this is the new angle that I want. So I've drawn my branch, I've translated to the top, and I want to rotate to draw the branch to the left. And you'll notice that I'm multiplying by I. So this is going to be a negative off to the left, and then the central branch I'll rotate by 0. So the angle will be 0, it'll be straight up, and the branch to the right I'll multiply by positive 1, so that'll give me a rotation to the right. So now that I have the angle, I can rotate by that angle, and then I simply draw on the branch. And I want it to be the old length, but I want it to be a little bit shorter. So I will put in a random between 0.5 and 0.7. So it'll be between 50% shorter and 70% shorter. So this is what makes that branch a little shorter. And then I will pop that transformation off. So the idea here, just in terms of the coordinate systems, is first I translate to the end of the branch that I just drew, and then this push and pop rotates to the left, but then I pop that transformation off so I'm facing up again, and then I rotate the second time 0 degrees, so I'm still facing straight up, and then I remove that transformation, and then I rotate to the right to draw the third branch, and then I remove that transformation. And then just to get this all sorted out, I have to pop off that last matrix, which backs me up from the end of the trunk. And that becomes important when I start drawing these side branches. So this is a recursive procedure. When I draw this branch, when I'm done with all of its sub-branches, I have to back up here to draw that branch. So let's take a look at how this works. So there we go. I have my tree. But what's happening is it's going through the draw loop every time, and every time it's generating a new random tree for me. So I get all of this random variation. And in some ways that's nice because it shows me the amount of randomness I can get. And if you want more or less randomness, you can go in and play with these ranges. However, I don't want it changing like this continuously. So what I'm going to do is set a random seed for the tree the same way I did for the sky. So let's put that in. I'm going to come up here and say I want a tree seed. And I will pick a seed. And then before I start drawing my seed, I want to set that as the random seed that I'm going to use. So if you're not entirely familiar with how random numbers work, they're not actually random numbers. Technically, they're pseudo-random numbers, which means we get a sequence of numbers starting from some seed number. And that sequence has all of the statistical properties of random numbers, or at least most of the statistical properties. There's a whole research field in creating better, more random, pseudo-random numbers. But it is a sequence, so if I start before I draw each tree using the same seed, then I'm guaranteed to get exactly the same tree each time. If you play games like Minecraft, when it says set the seed for a world, you are literally setting the random seed. And if you use the same random seed, you get the same pseudo-random world. I'm doing that here to get the same tree each time. So now it's drawing this tree every draw cycle, but because I'm using the same random seed each time, I'm getting exactly the same tree each time. So that gives us our basic image. We've got the sky, we've got the ground, we've got the tree, but now I want to be able to do by my day-night cycle. The way I'm going to do that is I'm going to set up a time, and I'm going to have the time change as the simulation goes on. So let's come up here and add a time. And then I also need a time step, which is how much I advance time by. And the intuition might be to say, well, I'm doing day-night, so let's have time go from 0 to 24, as in 0 to 24 hours. Turns out that's not the best solution here. And the reason for that is if I want things to get dark at night, then I have to put in a bunch of conditions that say, depending on what the hour is, this is how the sky should change, or this is how the stars should change. If my numbers go from 0 to 24, there's not a smooth connection between a number like 9 o'clock at night and what those values should be. So instead, I'm going to use a little bit of trig to get a much better curve. So it turns out the time step, I'll just put it in for now, and then it'll make more sense in a minute, is going to be fairly small, because my day-night cycle is not going to be 0 to 24 hours. It's actually going to be 0 to 2 pi. And let me explain why. I have another little function here I'm calling time curve. This is not going to be part of the image, so you don't need to include it if you don't want to, but you can if you want. So let me expand it just a little bit, and you can pause and copy it if you'd like. I'm just using it as a reference, though. It's not actually going to be part of the final image. And all it's doing, although in a little bit of a complicated way, is drawing a little piece of a cosine wave, because I'm going to be using a cosine wave in my image. Now that I have it, I'm going to include it here in my draw loop, so we can see it being drawn. The idea is this is a cosine curve. So I'm starting at 0 and I'm going to 2 pi, and if you're familiar with your trig, or even if you're not, this is the cosine of that angle. And so the idea is going to be positive values I'm going to represent as daytime, and negative values are going to be nighttime. And now I have a much simpler mapping from the cosine, which I'm thinking of as the time, to things like how bright should the background be. So during the day, I'm going to use a lot of brightness in drawing the sky, and at night, I'll use progressively less brightness as drawing the sky. And I know that my values go from 1, so that's going to be my maximum brightness, down to -1, that's when I'm going to use the minimum brightness for my sky. And then when I add in stars, I'll do the opposite for the stars. So instead of using a 0 to 24 hour clock cycle, I'm going to use a 0 to 2 pi clock cycle. So again, 0 to 2 pi, and I'll take the cosine of that to help me determine how bright the sky should be or how bright the stars should be. And let me shift my window back over. This dot represents the current time, which doesn't exist yet, so I can add that into my code easily enough. There is my increasing time based on the time step. And if time gets to be 2 pi, I want to wrap back around. So if time is larger than or equal to 2 pi, time equals 0. And now if I run this, you can actually see the cosine changing. So the time is moving across, and the cosine of the time is going from positive values to negative values. It'll shift back to positive values. And then when I get up here, it's going to wrap around and the day-night cycle will start over again. Now that we have our times, we can incorporate that into how we draw the sky. So let's do that next. And so I'm going to come down to where I draw the sky. The hue stays the same, but I'm going to change the saturation and brightness based on my time. And I want to do a mapping because I know the cosine goes from -1 to 1. So I'm going to use processing's map function, and I will take the cosine of the time. So that gives me that curve, and I know that ranges from -1 to 1. And I want my saturation to vary between 0 and 100. And so the idea is, in the middle of the night, my colors are not very saturated, and at sort of noon, when cosine is all the way up there at 1, my colors are very saturated. And it's reasonable to ask, well, why do you want some colors even at midnight? And the answer is because the brightness will also decrease. So I've got a little bit of color, but mostly almost no brightness, which means they're going to look pretty black. And so I'm going to do the same thing here for my brightness. And I'm just going to put it underneath so we can sort of compare them. Same idea, map the cosine of the time, which varies from -1 to 1. But here at the minimum point in the middle of the night, I want almost no brightness. And at sort of high noon, I want the maximum brightness. So let's take a look at this. And I am missing a closing parenthesis. This one closes the time function. This closes the whole stroke function. So there we go. And now as it gets to be nighttime, we should see both the colors fade and it gets darker. And you can adjust the mapping function to sort of change how this works. So at midnight, I still get a little bit of color, maybe more than I want, in which case I can adjust those limits. And then we get back up to the maximum brightness. And the day cycles and it gets dark again. This is running a little slow, so maybe I'll speed it up if I want by changing the time step. So I could say instead of 0.16, I'll do 0.26. This will zip a little fast, but for programming purposes, this is useful because I can see it cycling more quickly. And you notice, as usual, I get a different random tree each time. So there we go. The next thing I would like is to get a different random sky each time, because you'll notice as the day comes back up, I'm getting the exact same sky as before. So what I want to do is regenerate the sky, and I want to regenerate it effectively at midnight. So I'm going to put in a condition in my draw loop to say regenerate the sky if the time is right. So if the time is larger than pi, which is right about at midnight, and the time is less than pi plus my time step, I'm going to regenerate my sky, so I'll get a new sky. And there's a slight chance that I will exactly hit one of these limits, so I'm going to do it as less than or equal. And if I run this, we actually won't see anything change. And the reason we won't see anything change is the tree is setting the random seed to be a fixed value. And so because I'm using a fixed value for the tree seed, I'm going to also be getting the same time seed, if you will, each time. So it actually generates the exact same pseudo-random sky. And to fix that, I have to change my sky seed. So let me put that in, and then it'll make a little more sense. So here's where I generate my sky based on the random seed. When I'm done generating the sky, I generate a new random seed that I will use for the next sky. And this needs to be an int. And if I did all of this correctly, now we'll see as we go through midnight, we get a new sky the next time around. Right? So you can see we got a lot more yellow this time than we did last time. We keep the same sky. It gets darker and darker, and then you see a little bit of variation, and we get even more yellow as it turns out this time. So that works well, but we're getting the same tree because we're using the same seed for the tree each time. And might be we want a little more dark here. If that's the case, we can go in and say, well, I want the limit on the sky to be completely black. But that is up to you. So now we've got the sky fading in and out. The next and last thing I want to add are the stars. For the stars, I want an array of all of their locations, and actually I'll also put their radii into that array. And I'm going to take advantage of processing p vector, which is a 2 or 3-dimensional vector. I'll use all 3 dimensions. I'll use the first 2 for the xy location of the star, and the third one, interestingly enough, for the radius of the star. So I'll have stars with different radii. So I need to create that array. And I'll put in the number of stars that I want as well. And then in my setup, we'll create the array and call a function to generate the stars for me. That creates the array. And there's the function that doesn't exist yet, of course, to generate the stars for me. And I'll just put that in here. So there's the number of stars I want to generate. And each star will be a new p vector, and I want it randomly on the screen. So random width and height. And then I'm going to do something a little tricky for the radius, which I think works well. I'll put this on a new line just so it's easier to see. So what is this doing? Well, I'm taking a random number between -5 and 3. So the biggest radius I can have for a star is 3, which is still a pretty small dot. In theory, the smallest radius I can have is -5. And the way processing works, that'll actually draw a circle of radius 5, which is not what I want. So I'm using my max function here to say, well, take the maximum value between 1 and whatever this random number is. So -5, -4, -3, all the way through 0 will all be replaced by a 1. And what that means is I'll have a whole lot of stars of radius 1 and a few stars of radius 2 and 3. And so it's a way to fake a distribution that is generating the stars for me, and then I need to draw them, and might as well do the draw function first, and then I can add the draw function into my draw loop. So this is going to be my function to draw the stars. And first, before I forget, I want no stroke, I want no outline around them. And I'm going to use an alpha value. Alpha is effectively the transparency, although that's actually a little bit backwards because an alpha of 100 means they're fully opaque. So alpha is often referred to as transparency, but 0 alpha is maximum transparency. So if you sort of think about it in that scale, it's a little bit more like opacity. But you can treat it either way. Just remember that a small value means they're more transparent, and a big value, like in my case 100, it's going to be the max, means they're fully opaque. And then I just need to go through and draw all the stars using their location. So this will draw them using the x component of that p vector, the y component of the p vector, and the z component of the p vector as the radius. And I haven't used the alpha yet, so I'm going to put in for now just a temporary fill. This is officially filling with the hue of 0, which would be red in my color wheel, but I'm using no saturation, so there's actually going to be no redness. And I'm using 100% brightness, so they're going to be very bright with no red, which means they're going to be white. And then I'll come up into my draw loop and say, well, let's actually draw those stars. And so now I have all of the stars, but you'll notice they're out during the day as well as at night. And I also messed up slightly putting the wrong order in. They're on top of the ground. So I want to draw the stars before I draw the ground, and in fact, before I draw my tree as well. Okay, so let's go ahead and put that in. Draw my stars before I draw the ground. Now they don't show up on the ground anymore, and I'm drawing the tree last, so they also are behind the tree. So getting that order right is important, Sort of glad I messed it up just to show you how it works. But I want my stars to disappear during the day, so I'm going to use the same sort of mapping that I did with my sky, but in a sense reversed. So let's go ahead and do that. When I draw my stars, the amount of transparency is going to be tied to that alpha value. And it doesn't have a value, so that's why I'm getting an error message, so I need to set it. And I'm going to do the same sort of mapping. And this is going to look a little odd. I spent a lot of time fiddling with it to get the effect I wanted. You can certainly change it if you want. So first I'm going to emphasize the cosine a bit so that I get a stronger range. And the reason for that is I'm going to subtract from that the radius of the star. There we go. Let's spell stars correctly. The bigger the star, the more negative this number is. And because I'm subtracting the radius, I actually get a range from -4 to 0. And I'm going to reverse things a little bit. So -4 is at the lowest point, and so that's when I want the least transparency. And then when that value gets to be the most positive, I want the most transparency. And I'm actually going to go not to 0, but to -100. So for a big portion of the day, my transparency is in the range 0 to -100, which is fully transparent. And then for a bit of the night, the negative values, because cosine dips down, I get full opacity. And so if we put that in, we have no stars during the day, and then as it gets to be night, the stars come out. And you'll notice it's subtle, but I think it's sort of valuable. The larger stars show up first and fade away last, and that's because the radius, the z, is part of my mapping function. So it's not just a matter of what time it is, but also how large the stars are. So it's a little subtle, but I think it works well because it gets those stars to show up late at night. Now, of course, if you've included my cosine, you probably want to get rid of that, so I will get rid of my time curve. That was just as a reference point, and now we have the full scene. What you'll notice is we don't have the shooting star. I'll leave it up to you if you want to add that. All sorts of things you could add. So, I thought a lot but didn't put in, for example, a moon, and maybe a moon that waxes and wanes as time goes by. You could maybe add some silhouetted birds that move by during the day. You can certainly call our branching function more than once from different locations, so it's easy to add additional trees if you'd like. Lots of cool things that you can add. And of course, that is the key to sort of improving your programming. Don't just copy what I did, take it and expand upon it. If you've got any really cool ideas, any things that worked really well for you, please feel free to add them to the comments down below. Thank you.